So there we go. So welcome everyone to our MESA STEM series, and thank you, Dr. Canavan, for joining us and for hosting a session for us. A few being notices before we get started. It looks like there's a few people, which is great on, but just for the sake of fluidity and just to make sure we save our bandwidth, if you are not talking, if you can please go ahead and make sure that you're muted, just to eliminate any background noise, and also to turn off your video camera. We found that helps with making, less interruptions as they're going through. And then, any questions that come up, feel free to, unmute yourself or turn your camera as appropriate. We can also utilize the chat box. So as we go through, I'll be monitoring the chat box and, just seeing if there's anything I can answer, or, just kind of watching that as we go. But for those of you that are on the line right now, if you are a MESA student or a MESA teacher, I will put in the chat box a link to just to verify your attendance or to get you credit in our MIMS program for your loyalty award. So if you are a MESA student or a MESA teacher, please go ahead and complete that quick survey. It'll just take a couple of minutes. And if you're here with the summer program, just enjoy. I don't know if there's any other tracking that Steffi had needed, but otherwise than that, we will go ahead and get started here, here now. But thanks again for coming on, and I'm going to go ahead and mute myself now. Thank you.
So hello, everyone. My name is Heather Canavan. I'm a professor of chemical and biological engineering here at the University of New Mexico. I was actually born here in Albuquerque. My dad was in the Air Force, so was my grandpa. So I was born here on the base. And then since Dad was in the military, we moved around a whole lot. So I graduated from Los Alamos High School, go Toppers, in case anyone's here from the Los Alamos area. But then I went to school in California, Washington, D.C., and Seattle. And that's what most professors end up doing, frankly, is moving all over the place. I came back to UNM in 2005 to become a professor here in the department and in the School of Engineering. At that point, there was a big push to increase the amount of biomedical engineering instead of just straight chemical engineering that people were doing here. And it was students that were interested, as well as the legislature wanted to see more biomedical engineering here, and so forth. So I'm going to talk a little bit about what sort of research I do in biomedical engineering, which you might not have ever heard of before. I'm going to use some slides so that you can see kind of pictures of what we're doing. And then if we have time, I'll give you a little tour afterwards. Just to start off, I am at UNM right now. I'm in my office here at UNM, and the university has been closed down since spring break, but people who are professors and staff members like me are allowed to come in on a limited basis in order to do some of our jobs. I thought that I would come in today because this is a good place to talk, because my dogs won't be barking at you, but also if I can give you a little tour of what kind of stuff we're doing in the lab while the shutdown is occurring, I thought that would be kind of interesting. Okay, so the first thing I'm going to do is I'm going to take over your screens. So here we go. And I'm going to show you this PowerPoint. And Anita, could you turn your mic back on for just a second?
Yes. Yes.
Okay, great. So what I'm going to do is I'm going to try and show my presentation, but I know sometimes it doesn't work super well. So can you see the Adaptive Design main screen right now?
Yes, I can.
Okay, and does that look like a normal slide for the next one that I just advanced to?
Yes, it says research and personal background. Perfect.
Okay, great. Yeah, I tried doing this with another group before and they were like, your slides aren't moving. So I thought I would do that right away. Okay, so this is just to recap. What I'm doing is called adaptive design. And here's my background. Like I said, I was born here in Albuquerque in 1972, got my degrees, and then in 2015, I actually was diagnosed with breast cancer, and I was treated. It was caught really early, and I was very lucky, but I also thought maybe this is a good time to change what kind of research I do. And in particular, I was interested in helping people, not just in terms of detecting something like detecting cancer, which a lot of people do. In fact, one of my colleagues who works right next door works on detecting Alzheimer's disease and Parkinson's disease and all kinds of stuff. Engineers work on that sort of stuff too. But I thought what I would work on instead is, let's say someone has been diagnosed and they've been treated, how do we help them lead a happy, independent, successful life afterwards? All right, so that's what this is called, from bedside back to bench. So the idea is we've gone to the patient, we've learned about them, and now we're going back into the lab to try and make new solutions. And a lot of the research that's presented here, I did with a graduate student of mine named Phong Nguyen. And Phong actually is also from New Mexico. She was born in Vietnam, but she moved here as a young girl. She went to high school and undergraduate here and then joined my group. And we actually formed this company, Adaptive Biomedical Design, in order to do some of the research and support it that we're doing at the university. And in this lower corner down here, that says using human-centered design to direct research. And what that means is, instead of thinking about the end result of we want to detect cancer or we want to build a better fuel cell or something like that, it's really how do people interact with the items, and then how do we make them better, easier to use. All right, so here I have a question. Which project would you like to hear about first? Shower Shays, Bubble Light, Be Positive, or the Wheelchair Sidekick? And I know that Anita just asked you to turn off all of your cameras, so I can't ask you to give a thumbs up, but perhaps you can take over the chats and tell me, of the 4 projects, which one sounds good? This is one of the rare chances when a professor is gonna let you vote. This is not dictatorship. I always tell my students, it's not a dictatorship, it's a benevolent, kind of society that we go with. So Anita, perhaps you can unmute and tell me which one has the most votes.
Yes, I'm unmuted now, but I was actually going to try to set up a question.
Okay.
If I can do it.
I see 2 bubble lights, 3 bubble lights, bubble lights, bubble lights, bubble lights. Okay, we'll start off with bubble lights and then we'll go on from there, okay? So the bubble light project is a great choice. I'm gonna go back here. I'm gonna skip through. Here's bubble light. Okay, so these are some of the students and other people that I worked with. Up here in the top left, this is Darnell Kyler. Darnell grew up in Las Cruces, New Mexico. He came to UNM and started to work with me when he was a sophomore. He graduated 2 years ago, and now he is getting his PhD and also a dentistry degree, a DDS, at the same time. So at Stanford, no, UCSF, sorry, University of California, San Francisco. This is Phong Nguyen, who I already told you a little bit about. Phong has graduated with her PhD, and she'll be starting medical school in the fall. And this is a friend of mine who is a professor in Australia. Her name is Sally MacArthur. So these are the people who worked on the project. And what's the problem? So this is me here, and this was probably about a year after I'd had breast cancer. And what the problem was that we were working on was, for those of you who are in the audience who are older, you know that when someone reaches the age of about 50, they're told that they need to do a colonoscopy. And that is because the risk of colon cancer is higher as you get older, and it's one of the best tests that you can have. It's 85% of cancers are caught really early when people have that kind of a test. However, the way that the treatment occurs is so uncomfortable and so gross that a lot of people who've had the test before won't reschedule it if they have to do it again, or a lot of people will put it off until the very last minute. And that's because here in the bottom left corner, you can see this big jug. That's 4 liters of water and then this chemical that's called PEG that you have to mix together and give it to the person in order to make them clean out their insides, which is as gross as it sounds. But the problem is this dosage was basically something that it was never optimized for human consumption. It was tested on 4 or 6 men that were white men back in the 70s, and then they never tried to look at, Was there a difference in terms of if women were taking this treatment or if men were? They didn't look at the size of the person. They didn't look at their age. And so what happens is a lot of the people that do actually take this prep, this PEG prep, makes them really sick and they can't finish it. And that means that they're not able to complete their test. And so I had to have this, unfortunately, as a part of my treatment for cancer. And I came back from that and I told my student Fong, I said, this was the grossest part of my entire cancer treatment. I would rather go through surgery again than have to do that prep for that test because it's so gross. And I thought, this is an amazing tool, but because it's so gross for people to handle, people aren't going through with it. So how can we improve this? How can we make the prep more palatable? And as I said, Fong, who I show in this picture right here, she's from Vietnam, and her sister had a sandwich shop that sells boba tea. Have you guys ever had boba tea? So boba tea is something I'd never had before because I'm ancient, but it's basically this stuff that's in the middle right here that you can have whatever kind of drink you want. And then it's got these little bubbles at the bottom that are tapioca balls. And because it was a gift from somebody, I drank it, even though I never would have ordered it on my own. And then I was really curious, what is this stuff made of? How do they make it? And she told me all about boba tea, and I had this light bulb moment, aha moment, which was the thing that's so hard about drinking this jug of liquid is that you're supposed to drink this entire jug. And like I said, it's 4 liters or a whole gallon. Imagine a whole gallon of milk that you're supposed to drink within an hour. It's a lot of liquid, and then it's really viscous and gross. And I thought, well, what if we could take this polymer that's in this stuff and make it into the bubbles like a bubble tea does. And then the rest of it is whatever drink you like. Because I can imagine I couldn't drink a whole gallon of milk in an hour, and I couldn't drink a whole gallon of this stuff, but I could easily drink, a lot of soda, or I could drink a lot of tea, or I could drink a lot of water really easily. And so that was the idea. How do I make this polymer be stable when it's in a liquid, and then when it hits your stomach, release everything that's in it? And so that's what we did. And the fancy name for this is a hydrogel. And if you look at the top left corner, you can see that this polymer basically cross-links when it's in a certain pH, and it keeps all of its stuff inside of it. And then when it hits a much lower pH, like your stomach, it'll release all of its contents. So some of you I know are in high school. You may have done the experiments with Steffi or someone else where you use like alginate and you put droplets into a water that has charge in it, and you'll see it form into worms or droplets. Have you ever seen that happen? This is the exact same thing. It's basically that whatever charge you have in the solution can change the environment so that the polymer will link or unlink. So it's basically unzipping itself, a zipper that's closed, a zipper that's open. And so what we did was we created a system where it has really stable bubbles at pH 7, which is about what all of your drinks are. And then when it hits your stomach, which is far more acidic, it'll release all of the medication. And so what are some of the other benefits? Well, if you look here, you can see, you can count out the number of bubbles that are in this drink. So that means like Steffi is a tall woman, but she's smaller than me. So we could figure out, well, if Heather needs 20 bubbles, maybe Steffi needs 15. And Fong is a tiny person. She's about 5 feet tall and probably weighs half what I do. So in that case, she might only need 10 bubbles. So that means you can tune the dosage to what the patient needs instead of what currently happens, which is that everybody gets the maximum dose. And that can have a lot of downsides. People can actually pass out from taking too much. Another thing that you can do is you can say, well, not only am I going to encapsulate the drug itself, but I can put in electrolytes, some other medications so that people don't feel sick, sugar to make it taste better. And the whole idea here is you're still trying to get the same outcome, which is that people are going to take the test, but you're going to make it taste better so that their compliance is better, so that fewer people actually have cancer. So here are some of the experiments. I'm not going to go into this in gory detail, but really what Fong and Darnell were trying to do was show we can tune the pH at which it's released. We can tune how much of the medication is in the bubbles. We can make sure that they're stable in like a liquid like water, and that they'll release the medication that they're supposed to do at the right amount of time. And so here is the outcome. So this was something that was really new to me. Like most professors, I had never done anything that was patentable. I had mostly just worked on very basic research that might be turned into a product later. But I thought, you know, this is something that could really change how people approach this kind of treatment and prevention of cancer. And I thought, you know, I'm going to file a patent on it. So Fong and Darnell and I are on that patent. They went through the I-Corps program, which is something where a student gets to lead it and learn how to market these things. We won a couple of awards on it. And we have down here in the left-hand side, one of my students made this UPC code so you could actually go to the website to see more about it. So that's the Bubble Light project. Like I said, it came from this idea of bubble tea. And the reason I like to talk about this project is because this was a project where I had experience as a patient that said, this is a problem. We should improve this so that people are more likely to comply with the treatment. And then by talking with a student who had a very different background, you know, like I said, she was Vietnamese, her sister had a bubble tea company, then I got to experience that. And we worked on this together to come up with this idea. And that's one of the great parts of doing research, is learning from other people about things that you don't know in order to create something totally new. Okay? So that's the Bubble Light project. I'm going to look up here at the chat because it looks like there's a couple of questions. I love boba, says one student. I grew up drinking it as a delicious summer drink. I agree. I am a total convert to boba tea. I thought it was really weird at first because I didn't ever have tapioca, and I was just like, I don't know how that's going to work, but it's actually really tasty. Another student says, boba tea feels weird in my mouth. I agree. The feeling is a little bit different. And so what I thought was, have you guys ever had gummy bear vitamins or like little chewy vitamins? You don't necessarily have to chew them. You could just swallow them. And I thought, well, they could do that too. They could just take it like a vitamin if they need to do that. Another person says, I need to try it. And then it looks like people are voting on some of the other projects. All right, so let's see. It's 1:20 right now. Yes, it's chewy, but you get used to it. I agree. What would you like to hear about next? I'm going to escape here, and I'm going to go back up. All right, would you like to hear about the shower shays, the test tubes, or the sidekick? And I'm going to pull the chat back up. Shower shays, test tubes, test tubes. I see a couple test tubes. Shower shays. Actually, it's a pretty neck and neck. So I'm going to talk about oh, look, we've got a fancy poll in here. So go ahead and answer the poll. Looks like we're neck and neck right now. Test tubes are winning by just a nose. All right, so we'll go with the test tubes next. Okay, I'm going to end the poll. And thank you for setting up that poll. That was really speedy. I like it. Okay, so now I'm going to go back to the talk, and I'm going to go down to the test tube. And this is another great project because it involves Fong, who was my graduate student at the time, Darnell again, and then this in the bottom left-hand corner is Wendy. She's a nurse here at UNM Hospital. And this was actually her idea. She came to us with this problem and said, I have this problem. I really want you to help me solve it. You guys are engineers. Okay, so what is the problem? Well, there is this problem that, I don't think I have a good picture in here. Okay, have you guys ever had a blood draw where you go to the hospital or you go to like a clinic or something and they put in a needle in order to take out blood tubes? Let me look at the chat. Okay. Yes. Okay. So have you ever noticed that they can take a whole bunch of different tubes and they have different caps on them? If I go to the next slide, you'll see up at the top right-hand side, they have different colors. There's yellow, light blue, red, yellow, green, dark green, lavender, and so forth. What each of those tops mean is that is a different type of test that they're going to run for that. So for example, some women have anemia. It's really, really common. So they might want to test for how many red blood cells that person has in their blood draw. They might also be testing for something like, do they have high blood pressure or cholesterol? If you know your parents or your grandparents, they may be taking medication for that. Those are tests that you can do with the blood draw. There are all kinds of different tests that you can do with blood draws. And each of the tubes that they take with the different tops, well, inside of the tube, there's something else that's been added in order to make that test happen. And so what that means is nurses like Wendy are supposed to use a really rigid way of taking the blood draw. You're always supposed to take it in this order up at the top right, where it's yellow, light blue, red, other yellow, light green, dark green, lavender, etc. And the reason is because if you mix up, say, red and yellow or lavender and yellow, what can happen is, you know, they've put the little thing inside of your vein, and now they're drawing one blood after another. Well, the additives that are in the tube can actually cross-contaminate another tube if you take it in the wrong order. And so what has been done in nursing for decades is that they have what's called mnemonics, which are memory devices to try and remember what the order of the draw is. And so you can see there's stoplight red, stay put green, and then light go. And so what that means is you're supposed to remember stop means sterile, and then light means light blue, and then red is red. Stay means SST, which is a specific type of test. And then put and green are a different type of test called PST, and then green, and then lavender and gray. The thing is that Darnell actually did a test of new phlebotomists, which is the fancy name for people who do blood draws. And all of them swore that they knew what the order of draw was, but 30% of them to 50% of them would get it wrong. And that's right after they were in class for this. With nurses who have been there for a really long time, the percentage is even lower. And so this can be a real problem because, like I said, it can, if you take blood in the wrong order, it can mess up what the results are, and that can mean that the doctor interprets the results incorrectly. In particular, if someone's getting ready for surgery, like I was, they want to make sure that the person has enough calcium and potassium because those are electrolytes in your body that are important to keep you healthy. And if the number is really far off, they may reschedule the surgery and put the person further behind, or they could have them cleared for surgery when they're really not ready to go. So this idea that we had was to create a forcing function, which is a fancy engineering word for just take it out of the memory at all, altogether, and make it something that really helps people do the thing correctly. And it's going to force people to use the order of draw, and then it's going to help the people, also the nurses, deliver things correctly. And the reason I like this project so much is because this is something that Darnell worked on. He came up with the prototype. It was a fancy test tube rack, basically. He was the person who helped me file a provisional patent on it. He did an I-Core project based on this. And again, in the bottom right, here's this QR code so that you can see more about the project. But the idea here again was, Wendy is a nurse and she's got 20, 25 years of experience in the hospital, and she knows this is a problem just to remember the order of draw, that whole light blue, stay put, red, something. I can't even remember when it was on the last slide, right? And so she was saying that's under best case scenario. What if someone is in the emergency room and you're trying to do this and they're in a lot of pain? You don't want the nurse to be distracted by trying to remember this mnemonic and not do their job correctly. So this was an idea that came to us from a member of the community that saw this as a problem, and we were like, hey, let's look at this. Let's see if we can create something for her. So that is patented with Wendy, and it's going through the patent process right now. All right, so at this point, I'm gonna come back and see if there's any chat up here for people that are curious. Someone says, I'm in the car and my service is a bit spotty. Okay, all right, at this point, what I'm gonna do is I'm gonna skip to the last project, which is Scrub Hub ABQ, okay? So here, this is a project that I started with my students and some other members of the community. And so all of us know that your classes were canceled, you didn't get to finish the last of your school year at school, everybody had to homeschool. That's the same thing that happened with the university. But I thought we should use our expertise and the things that we have in order to help people who weren't prepared, okay? So I'm gonna show you what Scrub Hub is doing. So the idea here was my group was using adaptive design again in order to say, how can we help? We're not gonna be able to cure the coronavirus. That is something that is gonna be, a long-term project. We know it's going to take maybe like 18 months to develop a really great vaccine. But in the meantime, what can we do? I know that I have 3D printers. I know that I have a lot of friends who can sew. I know that as chemists, we're able to make hand sanitizer because it's basically just two different chemicals mixed together. And then the other thing I was thinking about was some members of our community have had a really hard time because, so I work for the university, which means that I'm on a contract that I get paid whether I'm working from home or I'm here in my office or I'm teaching a class. But people who work in restaurants, bartenders, people who are hair cutters, all kinds of stuff, they weren't able to do their jobs. And so what's scary is not only does that mean they don't have enough money to, pay their bills, get groceries and so forth, we know that people make riskier decisions when they don't have a financial, when they don't have enough resources. And so I thought, well, what I could do is pay volunteers. I know that sounds weird to say volunteers are getting paid, but I paid volunteers in order to make things for members of the community who couldn't afford it. And by that, I mean fabric masks, like you see these two students wearing, as well as hand sanitizer and face shields for people in the hospital. So here on the left, this is Johnny. Johnny graduated with his master's in biomedical engineering. Before he came back for biomedical engineering, he was actually a paramedic. And before that, he was a Navy SEAL. On the right is Nika. Nika is a graduate student in biomedical engineering who just started. And she's also from New Mexico. Both of these students are from New Mexico. And what you see is in the back on the left-hand side, that's my truck. This is really my garage. That is my kitchen table. And they help me take 3D printers home in order to make face shields. And I'll just skip that part. But I will say that the whole idea of having these people drive around and deliver things has really worked. We've delivered, I think, 400 masks already to the Native American communities. And then our other arm that I think you're going to hear from Christina Salas later has actually done face masks and all kinds of stuff for healthcare workers as well. All right, so at this point, what I'm going to do is I'm going to go back to the chat. Chat. Okay, awesome. My battery is 12%. Okay, I think we're going to lose you, Elijah, but I'm glad that you guys enjoyed this. So I'm going to unshare my screen if I can figure out how to do that. Stop share. And what I'm going to say at this point is, so it's 1:30, And I was thinking that I could show you around the lab a little bit, if that's what you would like. So do you think you could do, Anita, could you do another poll and say, like, would you like to see the lab? I'm seeing lots of yeses. Are we allowed to see your work?
Yes.
Absolutely. Well, we're getting a lot of yeses. So what we're gonna do is we're gonna go into the lab, and I've got you on my laptop, so I apologize if I make you sick walking around. I probably should have done this on my phone. But there's no one else here except for one of my students, and so
my battery at 7% right now.
Sorry?
My battery's at 7% right now.
Okay, well, just stay on as long as you can, and when it dies, there's going to be recording, so you can watch the rest, okay? All right, so I'm walking through the hallway. It's really quiet here because I'm the only person aside from my student. And that's why I'm not wearing a mask, because I've been the only person here and I've disinfected it every day. So I'm not worried about that. But we're walking through the hallway, and then I'm going to take you into the lab. So let me get out my swipe card. We have swipe cards with our logo IDs. I don't know if you guys use those ever. It's very quiet here. This is Elsa's office. I'm walking past right over here. You're going to see it behind me. I'm swiping in. And now we're walking through the main lab area. And it's very quiet. You can see there's almost no one here. Which normally would have lots of students doing experiments. But right now it's really quiet. More lab benches. You can see there's wheelchairs in the back for one of the projects we were working on. Now I'm going into the tissue culture lab, and this is where we're doing sterilization of the masks. So people are bringing in fabric masks, and we're sterilizing them so that when they're delivered to places like the Navajo Nation and other places for people who are at risk, they know that they have no contamination. So do you see behind me, there's this cabinet, and there's a bunch of fabric masks in there, and they're all on aluminum foil, right? And if I turn the lights off again, you see that the light is blue. So that's a UV light, and UV light is part of the components of sunlight are UVA, B, and C. And if someone like me who's super pale goes out in the sun too long, we can get burnt, right? The same kind of light can be used to sterilize things. And this biosafety cabinet can sterilize 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 masks at a time. And then we've got more being sterilized in here. And then there's actually, so that's one lab. There's another 4 of them that are going right now. So that means that all of the masks that people are making all over New Mexico, we're picking up and bringing them here, sterilizing them, and then they go out to the various Navajo, Pueblo, the Ute Reservation got some, and the Zia Pueblo, Cochiti Pueblo, and OK Owingeh. All right, do they have to be separated when being disinfected? Yes. So just like, you know how when you wear clothing outside, you'll get a, if you wear a t-shirt, you'll get a farmer tan, they call it, where only your neck gets burnt and your arms, but not where the shirt covered. It's the same thing with UV sterilization. And so if there's something covering up that mask, like if they're on top of each other, the UV sterilization won't work. All right. You can always look at the professor's websites, that's true. Many conferences have poster presentations, that's very true. In fact, Nika, who's here, say hello. She gave a conference presentation last semester. Any other questions? How long do the masks stay in? Is it UVC? That's a great question. So the masks stay in, so let's use my mask as an example. So my mask has an inside and an outside, and it's been proven from research that if you use UVC or just a full spectrum UV, that if you do 12.5 minutes per side, that's enough to kill almost any bacterium, germ, or viruses aren't technically alive, but it'll disinfect them. So what we do is we put them for 20 minutes, which is a little bit overkill, on one side, flip them over, and do 20 minutes on the other side. We also spray them with ethanol. Ethanol is also a disinfectant, so it helps kill off anything that might be on there. And this is important because people all over New Mexico are sewing the masks, and we don't want to get people sick. Like, you may have heard that Gallup, New Mexico had totally closed off the town because there was such a huge outbreak in that area. So we want to make sure that we're not bringing things into the community that can make them sick. Let's see. Would you be willing to visit your school? Absolutely. Invite me, I'm happy to come. I think that, you know, school will probably be back open again in the fall. And Steffi Weisberg, who helped set this up, she and I are good friends, and I'm sure she'll help me find out how to come see you guys. Hopefully at some point you'll be able to come back to the lab and see everything yourself too. Thank you, no problem. I'm always happy to answer any questions. Valerie is an advisor in Gallup. Oh, excellent. So Valerie, you may be getting to see some of the masks that we've been making. I also wanted to point out that, and Monica, hello Monica. I wanted to point out that all of this is donated. This is not something where there's a big grant that's funding it. This is all your friends and neighbors that are donating material, they're donating their time, they're working hard in order to create this stuff. It says, when the masks are removed from UV exposure, can they potentially get contaminated? Well, that's a good question. So when I was in the biosafety labs, that's all decontaminated. And so no one's been in there except for me and my student. We've sterilized everything every time we've gone in and out. We haven't been exposed to COVID. And then when we take them out of the hoods, we actually wrap them up in Ziploc bags and then put them in a box for storage. So they're completely contaminant free. So that is a great question. Thank you, Donna. Do you have to worry about ozone? Not sure what you mean, Steffi. What do you mean, am I worried about ozone? Ozone is basically, okay, so our UV light at our house makes ozone. That is true. So UV light, just like I said, sunburns can happen, skin cancer can happen. That's because the light that's coming from the sun, and also UV lights like this, is so intense that it can disrupt the intermolecular bonds, which is actually what kills bacteria and other things. Okay, it's also what causes cancer if people develop skin cancer. And it can also rupture the oxygen-oxygen bond, which then one oxygen can go off as a free radical and then form ozone, which is an O3 molecule. Ozone is, most people know what it is because like if you've ever fried one of your electronics, like you've played with a game and all of a sudden you smell a like weird burning smell, that is ozone being created from your electronics. So that's something you might have noticed. But when I was in the hood when I was in the lab just now, you saw that there were those big hoods and there was like a plastic sash that comes down. I didn't open it because I didn't want to change anything, but anything that's inside the hood that's been created by the UV light coming down and hitting the mass, well, that's all being evacuated by the air handling system. So we're not worried about ozone. If we have time, can you summarize the other projects, shower shades and wheelchair? They're dealing with bioactive polymers and cell surface interactions. Oh, great. Okay, so the other projects, cell surface interactions, that's what I did for my first 15 years here at UNM. It's also what I did for my graduate research. And the main thing that I started off doing research on is that if you are doing, let's say someone's trying to work on a cancer therapeutic, or they're trying to figure out how cells behave in response to like UV light or something like that. They're always doing those experiments in Petri dishes. And if you ever put cells onto a Petri dish, once they adhere, you can't get them to come off. And I started working with this polymer, which is called P-N-isopropyl acrylamide, or NIPAM, which is all over my website if you go to my website. And NIPAM is a really interesting polymer because when cells grow on it like they would at body temperature in an incubator, they'll grow on the surface and they'll adhere and they'll grow. But then if you take them out of the incubator and put them like on a bench top at room temperature, they'll pop off like a Post-it note and you can get it to adhere to something else. And the reason that's so interesting is because now you can start making organs. There's a researcher in Japan who pioneered this research, and he came up with like cardiac cells that he could pop off and then make multi-layer patches and then place those over the heart of a mouse. And he showed that they would reincorporate with the, like if a mouse had a heart attack, it would have a little area of cells that were non-functional anymore. And if you put this patch over it, it'll start beating again like the rest of the heart. So that was the kind of research that I did originally. I still have some students that are working on that kind of polymers doing what we want them to do in order to influence cell behavior. Unfortunately, I don't think I have enough time to go through the other projects with the wheelchairs and stuff, but they are on the website, and I can talk to you guys more about them offline, but it's 1:46, so I think that's kind of the end of our presentation time, unless Steffi or Anita, you wanted me to talk about something else?
No, I think that's great. What is the website? And so I can type that in the chat.
Oh, sure. So I'll put in two websites here.
Okay.
So my adaptive, whoopsies. I'm going to give this to everyone. So adaptive, shoot, I can never remember the name of my own website. About adaptivebiomedicaldesign.com. So that's the one, that's the company that almost all these projects are on it. It also has a lot of information on Scrub Hub. And then there's also Canavan Labs. Is it a .com? We'll see, canavanlabs.com. So .com. This is my group website, which has some similar stuff, but it also has a lot of stuff about school, like what kind of classes I teach and so forth. Okay. Do you have any other questions for me, Steffi or Anita? Looks like there's a lot of questions about filling out the survey.
Yeah, so what I did put it also as a link into the chat was you only need to complete that if you're a MESA student or a MESA advisor. We have a mixed audience today, which is great, but we do track our attendance, you know, if students want to get credit. So that's what that survey is for. But no, other than that, thank you so much for being here. I guess I can turn myself back on.
Okay. Well,
there, Sarah, I'm back on now. But no, I think that is it. I really appreciate you, sharing, just the different work that your students doing. A little FYI, so we have a National Engineering Design Competition, our MESA USA competition, which focuses, its basis is based in human-centered design. So exactly how you talked about, designing for a user, designing for a client.
Right. It's really important. I would say that's something that's been really lacking. And the example that I like to give that I didn't have time to talk about was the wheelchair project. Really started with, I have a student who's in a wheelchair because he has muscular dystrophy. And I had asked him one day, like, what would be something that you would love to see, that would be really a big deal in your life? And he said, I want a cup holder. And I just was like, what are you talking about? Like, the kids in this class have never lived in a world where every car didn't have a cup holder, and like baby strollers, everything has cup holders, but wheelchairs don't, and they never have. And I just thought that is crazy. And it's because you have the people that are designing the equipment aren't talking to the users of the equipment. And so what we're trying to do is pair those people together, either with patients like myself or with people like Wendy or my student, who just say, hey, this is something that we need. How do we figure out how to make that? So that's what adaptive design and human-centered design is all about. So thanks very much for having me come and speak to you guys today. I hope that you're having a great summer to start with. I know that this is a little bit weird to have this kind of online experience instead of what you're used to, but maybe other people will get to show you their labs too while you are at home and safe.
Yes.
One thing.
Go ahead.
One thing.
Yes, is that Steffi? Yes, please.
So you might have noticed when Dr. Canavan was walking through the lab, maybe not, but the lab was actually designed in a particular way to try to get scientists and engineers to affect their behavior. It's one huge big room with lots of different benches, and every professor has 2 or 4 different benches. And that was designed, it's very different than a lot of the other labs that you see at UNM. It was designed so that particularly the students in different labs could interact more easily and try to come up with ideas and to share knowledge too. So we're not only designing, problems that are out there in the world, but also trying to design for engineers so that they can help them come up with ideas as well.
So yes, so thank you for that. So no, I guess that is it. Again, thank you so much for having us. I will keep all your contact information handy. For anyone tuning in, this is our last hosted STEM series for the school year. Over the summer, we'll continue to promote, any other of our partner programs. Anything that they do have, we will promote it on our website and on our social media. But this is the last MESA hosted for the school year. And we will resume again our STEM series starting in August or the school year of next year. And so this has been one of those unexpected benefits of everyone being homebound, is that our STEM series has been able to launch well. We've been able to have a lot of great presenters. And so any of students tuning in, teachers tuning in, have a great summer, and we'll return back in August, hosting different STEM professionals across our state, or we've even had some from different parts of the country. So thank you all for joining us. Again, MESA teachers, MESA students, I'll put the link one last time, just make sure to complete that for attendance. And I think there was a question here about, was there the NASA launch follow-up? Yes, Elsa, let me actually, before I leave, I will put a link to where everything will be. So after this presentation is done on our New Mexico MESA website, you go to nmmesa.org. On the bottom left, it says featured event, and it's our COVID streaming showcase. And this is where we've listed all of our webinars and where we also post all of our recordings. So everything will be in this section. And on there, Elsa, when you go down to our NASA series, there's a link to like the launch kit. And that will take you to all of the NASA webinars and the links to NASA TV and everything related to the launch that you would want to see. Will all be, you know, put in that place. But as well as for here, when this recording is done, it will be placed up in that same place and the MESA website.
Thank you.
All right, well, it was very nice meeting everyone. Thank you so much for joining.